Good morning dear students. In this video I am going to explain entire 5th unit topics wise. So in 5th unit first topic is grid architecture and service modeling. So under this we are having 4 subtopics. We will see one by one. First one, grid history and service families. Second topic is CPU scavenging and virtual supercomputers. Third one is open grid services architecture. Last one is data intensive grid service models. In the first subtopic, grid history and service families, let us see the definition of grid first. The grid is a meta-computing infrastructure that brings together computers. That computers may be PCs or workstations, server clusters or supercomputers, laptops or notebooks or mobiles or computers, PDAs. So why we are just gathering all these things? Just to form large collection of compute storage and networking resources to solve large scale computation problems or to enable fast information retrieval for the registered users. Let us see the grid history once. So initially internet was developed in the year of 1980s to provide the communication between a computer and another computer using telnet protocol. So later the web service was developed in the year of 1990s to establish a direct linkage between the web pages using HTTP protocol. So due to the existence of the internet, so there will be a communication between the computers, right? So that's why ever since the 1990s grids became gradually available to establish large pool of shared resources. So in this topic we have seen grid history. So now let us see the types of grids, or grid families or service families. Everything is same here. So here mainly we have 4 different type of grids: computational grids, and it is also known as data grids. Second one is information grids, and it is also called as knowledge grids. Third one is business grids. Fourth one is peer-to-peer or volunteer grids. So now let us see the examples for all these 4 types of grids. For the first one, Terra grid, it is located in US. Next, EasyEE belongs to Europe. Data grid belongs to Europe. Grid 5000, it is located in France. China grid belongs to China. NAS, and it is established by NASA. LCZ belongs to SAN. eScience belongs to UK. D grid belongs to Nordic. Future grid related to US. Next, second type of grids, that means information grids examples are semantic grid, ontology platform, Bionic, D for science, Einstein at home. All these are the examples, and information power grid also are the examples for information grids. The third one is business grids. Examples are BE in grid belongs to Europe, HPE Speak, IBM WebSphere, SunGrid Engine, Microsoft .NET. All these are the examples of business grids. And the final one, last one is peer-to-peer or volunteer grids. The examples are SETI at home, Parasic grid, Phytates at home, Foldong at home, GIMPS. All these are the examples of peer-to-peer and volunteer grids. In this second subtopic is CPU scavenging and virtual supercomputers. Now we will see what is meant by CPU scavenging. For example, if we have considered the computers, those computers will not be used 24 hours, 24/7 period. So that's why unused cycles, unused resources will be created as a grid. So that is nothing but CPU scavenging. So the concept of creating a grid from the unused resources in a network of computers is known as CPU scavenging. So next let us see the virtual grid. Virtual grid in the sense, virtual means so there will be no physical connection, logically connected. So if you are having some computers, those will be free, those will not be used at the night times especially, and if there are no work, then that resources will be unused. So that's why virtual grids are built over large number of desktop computers by using their free cycles at night or during inactive usage periods. These client hosts also donate not only the CPU cycles, they can donate their disk space, RAM, network bandwidth, in addition to the raw CPU cycles. So many volunteer grids will be built based on CPU scavenging only. So one of the best example for this one is SETI at home. In this image, let us see the formation of virtual grid. In this picture, we are having actual organizations A, B, C. So those are the organizations, those are the physical resources it is having. And coming to the virtual organization X and Y. So those organizations will be formed by collecting the resources from actual organizations. So based on their requirement, means logically, so based on their requirement, what are the resources, storage or computing resources they need, those will be collected and will be formed as a virtual organization or virtual grids. Now we will see the third topic of this first topic, Open Grid Services Architecture, OGSA. So the OGSA is a open source grid service standard. It is jointly developed by academia, in the sense academic, in the part of academic projects, and the IT industries under coordination of a working group in the Global Grid Forum, GGF. So this standard was specially developed for the emerging grid and cloud service communities. The OGSA is extended from web service concepts and technologies. This standard defines a common framework that allows business to build grid platforms across enterprises and business parties. This is a OGSA security model diagram. At the bottom, we will have the security standards like transport protocol and message security. So at the left side corner, we are having key management, user management and policy management. In the policy management, we are having both authorization, privacy and federation. Next, antivirus management, intrusion detection. So this is a diagram which illustrates OGSA security model. So fourth subtopic is data intensive grid service models. Generally, applications of a grid are normally grouped into two categories. One is computation intensive, another one is data intensive. For data intensive applications, we may have to deal with the massive amounts of data because grid, so it is especially used to do the larger scale computations, right? So here also we need to deal with the massive amounts of data. The grid systems must be specially designed to discover, transfer and manipulate these massive data sets. So there are 4 different access models for organizing data grids. Those are monadic model, hierarchical model, federation model and hybrid model. So here we can able to see the images of these 4 different models. In monadic, here we will have a central data repository. Monadic model, so this is a centralized data repository model. All the data is saved in a central data repository. When the users want to access some data, so they have to submit the request directly to the central repository. In this picture, whatever we have mentioned, tape, institution, instruments and sensor, all these are the users, they want to access the data. So that's why they will submit the request directly to the central repository. Hierarchical model is suitable for building a large data grid which has only one large data access directory. So generally the data may be transferred from the source to a second level center, and from there some of the data will be transmitted to the next level. So like that, after forwarded to several times, so specific data objects are accessed by users directly. This federation model is a data access model, is better suited for designing a data grid with multiple sources of data supplies. Sometimes this model is also known as mesh model also. The last model is hybrid model. This data access model combines the best features of hierarchical and mesh models. So this is all about the first topic, grid architecture and service modeling in 5th unit. Once again, we will refer the subtopics: grid history and service families, CPU scavenging and virtual supercomputers, open grid services architecture, data intensive grid service models. In the examination, they may ask a subtopic as main topic also, so that's why we need to answer according to it. The second topic in 5th unit is grid projects and grid systems built. Under this, So first one is national grids and international projects. In this we are going to discuss about two different type of grids, national and international projects. Second one is NSF Terra grid in the United States, data grid in the European Union, and the China grid design. Actually, second, third, and fourth are the subtopics of first one only. Means in the first one only we will discuss national grids and international grids, right? So those are the examples of that grids. Generally, supercomputers will be funded by the governments only because they will have high configurations, right? So that's why. In the same way, national grids also mainly funded through government sources. These national grids are developed to promote research discovery, middleware products, and utility computing in grid enabled applications. Over the past decade, many data, information, or computational grids were built in various parts of the world. So, especially these national grids will be limited to the national geographical area. 5 representative grid computing systems built in US, European Union, UK, France, and China. So, in the next table, we will list out all those different type of grids and some information regarding them. So it is a table of national grids. Here in the first column we can see the project name. So later, so who has sponsored that one and in which year it has launched. And in the third column, so what is the capacity of that grid? So we will have. So first one, Terra grid. So it is belongs to USA and it is sponsored by NSF and launched in the year of 2002. And actually this is a open grid infrastructure resource sites with a 40 Gbps internet to backbone links with 2 PFLOPS computing power, 50 PB storage, and 100 specific databases. So second one is data grid. It is belongs to European Union and it is sponsored by EU and SER and SEN and it is launched in the year of 2001. So especially climbed the largest grid on earth for data analysis in high energy physics environments and bioinformatics. And the third one is grid 5000. So it is belongs to France and it is sponsored by French government and launched in the year of 2006. Regarding this one, it is an experimental grid comprising 5000 processor nodes in 9 French cities for HPC and research use. HPC means high performance computing. And the next one is China grid and it is belongs to China. It is sponsored by Education Ministry and it is launched in the year of 2005. So it is an educational computing grid especially for the research purpose and it is linked by using HPC systems in 100 Chinese universities. So this is especially built for the academic projects of the students academic wise in 100 Chinese universities. And the last one is NAS grid. It belongs to USA and it is sponsored by NASA AMS Lab and launched in the year of 2008. Regarding it, running genetic algorithms with the Condor cycle scavengers and large number of Sun and SGI workstations. International grid projects. Grid applications cannot be restricted to geographical boundaries, means those will not be limited to countries. These projects promote volunteer computing, utility computing. So generally international grids, they will involve both government and industrial funding both. So national grids are completely funded by the governments, but whereas international grids funded by governments and industrials both. These are some of the examples of international grids. EGEE, D for Science, Nordic D Grid, Future Grid, World Grid, SETI at Home, Boeing, BE in Grid. So all these are the examples of international grid projects. Generally international grids are based on the contract time period. So that's why in the third column status we are having some time period in which duration it is active. So this is the diagram of grid 5000 which is located in France. So here it is connecting all these main cities of the France. Second subtopic is NSF Terra grid and it is located in US. Terra grid include more than 2 PFLOPS of computing capacity. PFLOPS in the sense, so para floating point operations per second, and it is used to measure the computing capacity. and more than 50 petabytes of online and retrieval data storage. The TerraGrid is coordinated through the Grid Infrastructure Group (GIG), so at the University of Chicago. So this is regarding NSF TerraGrid in US. The European Data Grid Project (EDG). So it is funded by the European Union. This grid aims to build the next generation high throughput means HTC production quality grid infrastructures to support input output intensive experiments in high energy physics, earth observations and bioinformatics. So as we already specified all these things in the table, national grids table, so same like that only. So data grid information, so it is located in European Union. So this is a diagram of data grid. Actually based on the question asked, you need to give the answer. If they have asked for a single question, main question regarding national projects and international projects, then you can skip this diagram. But if they have asked regarding data grid only for 10 marks, so then definitely you need to prolong the answer, right? So that's why it will be useful, this diagram. The last one is regarding China grid. So it is located in China. So previously we have discussed China grid is completely, it is built for academic purpose, especially for the educational research in 100 universities in China, and it is sponsored by Education Ministry of China. This is what we have discussed till now. Second topic of 5th unit, grid projects and grid systems built. Under this we have discussed national grids and international projects, NSF TerraGrid in the United States, data grid in the European Union, and finally the China grid design experience.